Cool. All right. Hello, everybody. I'm Mike Page. I'm the technical director over at Out of Dawn. I apologize. We're going to be going through this very, very quickly. I've done a few timings and it's taken me like an hour to get through it at a reasonable pace. So I might skip over some bits, but if anybody wants to talk to me or they want to look at the slides or anything like that, chat to me afterwards. So we're going to talk about thinking about your users. And in this talk, we're going to have a look at three different groups of what I call users. We're going to have a look at their priorities when it comes to interacting with the systems and the code that you write. We'll take a look at the three major systems that Out of Dawn, and by Out of Dawn, I mean me, things that I wrote and things that we rewrote because we didn't focus on those priorities from the offset. So, first things first, though, I want to take a look at some of the reasoning behind that you hear for not doing things again and reworking things. This is the top one. You'll hear this a lot. There's no time for that. I'm going to go a bit quickly, but generally, oh no, look, going too quickly. You'll hear this a lot from production, and generally they are right. When it comes to reworking things, especially things that are live, they're probably not in the schedule. So one tip for this is, if you're going to ask to rework things, put a plan together, get estimates, get it scheduled into future sprints, etc., because just turning up like a week before you're supposed to launch something and going, we need to rewrite a load of this stuff is just going to set a lot of panic amongst people. If it ain't broke, this one you hear a lot as well. And it's like, this is why prototype code winds up in live games, is because if it ain't broke, don't fix it. I don't agree with this at all. It just leads to more and more problems. I can't use the scrolly wheel, so I'm going to have to drag this thing down. Oh my gosh. Okay. Another one is this one. And unfortunately, this one comes up from coders way more often than it ought to, which is they can make do with what they've got. Generally, this comes when they're talking about tools that they've given to designers or artists. This is a terrible reason, and we're going to get to tools a little bit later in my talk. Never make this an excuse for anything that you've coded. This one is another classic coder one, and this is something that I am guilty of, which we'll get to again in a bit, is like, but it's so good already. I've spent so long making this thing and I've made it pristine and I don't want to break it. And I'm not going to hear about breaking it. I don't want to rewrite it for any reason whatsoever. And a lot of this all boils down to this concept, which is this sunken cost fallacy. Okay, we've spent so long in time and money and effort and all the rest of it that we may as well just go with what we've got. None of these are particularly good reasons. So, first group of users, which is us lot, because we use our code, and it includes future you. Okay, I cannot stress this one enough, right? So, priorities for coders. I asked for each one of these, I sort of sat down, asked a bunch of people. Number one, coders don't want to break anything. All right, we want other people's code to be understandable so that when we have to go and interact with it, or we go to extend it, or if we just go to use it, okay, it's easily understandable. We don't want to make bugs, we don't want to cause problems. It needs to be robust, right? No one should have to assume that interacting with your code might break something, okay? I've heard this one so many times where people are like, oh, I finished this thing, but be really careful when you're using it, because you might cause catastrophic things to happen, okay? That shouldn't be the case. And the last one is predictable. Don't write code that does unexpected things. It's pretty simple. Okay, make sure your code does what it says it does. Okay, we'll get onto these. So, understandable. Write summaries for your methods, all right? We are, or historically I always say I am terrible at writing documentation and commenting the things that I do, okay? But quite often, a lot of what we do is kind of magic. We do a lot in our methods and our functions and everything else that doesn't make sense at first glance. So summaries, you can explain what it is that you're going to be doing in your thing. Single function, single responsibility. I'm going to have this on my tombstone, I think, okay? Because not only does it, splitting it up, make it so that it's far easier at a glance to understand, because your functions are small, but then writing summaries for them is really easy. It comes really succinct, little summaries, because nobody wants to read a page summary of the 2-page function that you've written. Don't be vague in your function and variable naming, all right? Don't do things like this. This is add time, time to add. Add time to what? And time in what? Is it seconds? Is it millennia? Who knows? Okay, I see this all the time. Okay, and oh, hang on, we'll get on to oh my gosh, this one, functions. This is getters and setters. Don't hide functionality in this. I've seen setters set multiple things, okay, even though they say that they're going to do. I've seen getters set things, which is just bonkers, okay? Again, when people come to look at your code, and part of your code is, hey, I want to get this value, they don't expect it to be doing something else. And yeah, this is the crux of this talk, okay, about coders. What's obvious to you now will not be in the future, okay? Everything you write, even when you're writing summaries and you're writing function names, you've probably spent hours or days or weeks or months building that system. You have so much context about what you are doing and how it works that no one will have. In a week's time, you won't have that context. Okay, in a month's time, you certainly won't have all of that context. And no one that ever interacts with your system will ever have that context. So you have to write your summaries and your code and structure it in a way that doesn't assume that people already understand it. Right, robust. God, I'm going at such a rate. Right, step 1 for robust code is make sure that it's understandable. Because the first way to make sure that people don't mess up your code is to make sure that they understand what it is that they're supposed to be doing with your code in the first place. No one should have to tiptoe around your code. Okay, don't expect, like, we're not dusting Fabergé eggs. Okay, you can't expect people to treat your code as being fragile. If your systems must work in a certain way, enforce it. Okay, I see this one a lot. It happens a lot in prototype code. People, you know, we leave every single thing public. We don't bother kind of splitting up into interfaces and all of that jazz because we're trying to get something that works. And then we never bother actually going back and fixing all of that stuff up. And we'll leave it so that people can interact with a system in many, many, many different ways. And then we'll be telling people, oh yeah, no, don't do it like that. You have to use it like this. Okay, but if you don't enforce it, somebody will use it in a way that you didn't intend for it to be used. So, like, yeah, don't have all public variables. Editors can be a real pain for this, and I'm looking at Unity. Unity's mildly obsessed with you making everything public just so you can show it to people. There is a way, like, you can do a lot of editor extension stuff in Unity to hide things and like show other things and make things read-only, etc. And use interfaces. This one would go just below single function, single responsibility on my tombstone. And if you want to know more about how I go about putting systems together, have a look at my other talk, which is the one from last year. Predictable. Like I said, don't hide functions in getters and setters. Be true to the function name and update it if you change it. Okay, this is something that I see a lot is, you know, you'll write a function like add 1 to the combat round count, which is great, and then somebody at some point will decide to go in and put a big if in there and go, well, if we're doing this, we're actually going to add 3 to it. But then they leave the function name exactly like this, so that everybody that uses it still thinks that it adds 1. Single function, single responsibility, extended. So we actually had something very similar to this. We had a delete data function, but the delete data function also always backed up our data before it deleted it. But nobody knew that it was doing that. So again, you split these things up, and yeah, and this is the one that you expose to people. If it's supposed to always back up data before it deletes something, make 2 functions, comment them, and then make something that just calls both of them. And that's the one that you make public. It's fairly simple stuff, but you really need to like drum it into yourself. And interfaces again. My partner decided that it was like a toaster. Okay, when you get a toaster, you don't expect to get like a full wiring diagram. You don't expect to be able to like pull parts out of it and replace parts out of it. You know, you want to be able to press a button that toasts. And you don't expect the toast button to suddenly start buttering your toast, even though you didn't ask it to, or stick Marmite on it. Okay, interfaces are there so that you can expose only the functionality that users of your code should be focusing on. And it also, anybody that comes along that has to like change your code or update it, gives it a really good place to start looking for where they should kind of go about changing things. Don't expect usage if you don't enforce usage, just like we said before. Right, so I do have examples. So I'm going to talk about the database system, and I want to preface this with, I am not proud of this database system. Okay, and this is going to be something that I'm going to skim over. So it's a very old system. I wrote it 6 years ago. And before doing this talk, what I wanted to do was, obviously, I was going to go through some of the code. And I was like, no, maybe I'll just do a little diagram. I got so confused by my own code, I had to ring the last person that had to use my code to explain to me how my code worked. Okay, that is how confusing it was. And I'm just going to skip past all of this, right? This is basically a rough diagram of how our database layer worked. There's weird things like, there were these like sort of fake interfaces, there were classes whose entire definition was wrapped in if-defs for some strange reason, because I didn't know what interfaces were. There was this data saver thing that would save stuff, but then wouldn't delete stuff, but would if it was local, but not if it was remote. There was this load data thing that would grab stuff from a remote thing, but then there was also a data loader, but that had nothing to do with the remote thing. Honestly, it was an absolute shambles in there, okay? And I think it's fair to say that from an understandability point and a robustness point, it failed miserably. The worst problem we had with it, though, was on the predictability side, okay? This is essentially what it would do. It would go off to our database, it would grab an object, it would give you that object, and then you would write that back, and you would await the result, essentially. Reasonably simple, but I would say extremely naive. Because the biggest problem that we had was if somewhere else in code, while this one was running, this one decided that it was also going to go and grab said object, it would get a copy of this object. Which basically meant that if you had two things running at the same time, you were guaranteed that whichever one of this finished last was going to stamp over the changes that the other thing was making. It was an absolute nightmare. It caused so many little bugs in our live data that, yeah, like we spent so much time in QA. And the reason for it was that when I built this, I had this expectation in my head that everyone was going to be like batching reads and writes. They were like, yeah, I'm going to write something, then I'm going to read it, then I'm going to write something, then I'm going to read it. I didn't enforce any of that. Okay, you could use it how you like, and people did go and use it however they liked. They would just be grabbing things left, right, and center. They didn't know if something was actually just about to write to the database. They didn't know if something else had priority or was about to change something that you were doing, because I didn't enforce any of it. So, what we get to. So this is the new one, isn't this lovely? Look, this is a lovely interface. And there's only really two functions in here, which is this one, push data changes, and this one, get. They're the only things that 99% of the coders that have to use this system have to worry about. And there is a local implementation of this, and there's a remote implementation of this. But the interface is exactly the same. And this one does this. It's great. So basically, it just gets data. And it will return an object very similarly to the last one. And you can make as many changes to this as you like. And if you get this data, you always get the current data. So anybody that gets it gets the current one. And what happens is basically every time you make changes, there's this whole really complicated system that works a bit like React in that there's all of these data changes get permeated by like an event system, and the database, the remote database, builds up this huge, great list of all of these changes that it needs to make. You can have hundreds of places in code all hammering changes into this database. And it doesn't matter. Like, you can use it exactly as I found out that people were using it. And when you're ready, you just push data changes. And that's it. And after a little bit of QA and, yeah, a few rounds of bug fixing, we've never had a problem with this in 3 years of usage. It works brilliantly, even if I do say so myself. Okay, however, sad news. The sad news was that for the coders that were on the project that still used the old system, it's really difficult to convince management and production that you should be allowed to go and change something like that. Okay, you know, just turning up to them and going, hey, we know it's been 3 years, but the database system really sucks. Nobody understands it. It's been so badly commented that even the person who wrote it no longer understands it. We'd really like the time to pull it out and start again. It's probably going to be a month's worth of work, and there's a load of QA involved, and we risk everybody's life saves, but let us do it. It's not going to happen, unfortunately. But when we came to do our next project, it was actually a really easy sell, and it was where I actually started with our next project, was the data. That's how bad it was. I started with the database system. Right, that was a whirlwind. Coders. Next lot of users, designers. Designers, so I sat down with a bunch of designers and asked them like what their priorities were for being given stuff from code. Funnily enough, top of the list, understandable. They wanted to be able to understand the things that you gave them because they have no context for what you have done. Okay, they don't know how things work. And more often than not, you just hand things over to people and go, you'll figure it out. It's obvious. Okay, but it is never obvious. The other one was usable, which I thought would be a given, okay, given that you're supposed to be giving people something that's usable. But apparently not, and this actually rang quite a lot of alarm bells with me, because I was like, are you really being given stuff that's not particularly usable? And the last one is focused, which we'll get onto in a second. So understandable. Descriptive variable seems really similar, right? But people want to be able to, in an editor or in Excel or whatever, read something and kind of understand what it's supposed to be doing from reading it. Tooltips. If your editor of choice supports tooltips, do use them. It's the first place that anyone will go to get extra information about the thing that they are using. And this one, which I'm terrible at, okay? But it's why technical writers exist, but they're really expensive, and very few studios can afford them. You wouldn't expect to get like a kit set with you'll figure it out as you go along, okay? Do write documentation for things. The things that we write are massively complicated most of the time, okay? And again, the context that we have can blind us to just how complicated the thing is that we're making. And then we hand it over with all of this knowledge going, well, it's pretty easy to use. You're like, it's not easy to use. It's easy to use because you're the one that made it. And what, as I've just said, what seems obvious to you won't be to anybody else. And this one, which I drum into my coders, use it yourself, okay? Not just once, not that one time that you put together like an asset and go, well, that worked, okay? Use it yourself. Ask yourself, what's it going to be like to use this 8 hours a day, 5 days a week for the rest of the year, okay? Ask yourself what it will be like if you have to go and revisit and change a bunch of the stuff that you've already made in this, okay? Because if you find it a pain to use your tools, or your editors, or your editor extensions, believe me, other people will find it even worse. Usable. Yeah, apparently, if it's not, apparently I have to say this, if it's not ready, don't hand it over like this. And I've had some very interesting sit-down chats with some of my coders when this one came up. Things can be work in progress. And if things are work in progress, find a way of hiding that away from your designers. Okay, sometimes you do have to put things out so that you can start getting some assets into a game, knowing full well that you're going to extend your tools and extend the system. Okay, but as I said before, people will just use what you give them. Okay, so if it's not ready, don't give it to them. Yeah, keep it simple. And this is where we're really going to focus, because for me, it's very easy. Like, I always want to make the most flexible, extendable system you can possibly make. And I wrote an entire talk drumming into people to make things flexible and extendable and all of this. There's a very fine line, though, because you can make it really complicated by trying to support too much stuff. So this should be keep it as simple as possible. Don't reinvent the wheel either. If Excel is a good tool for doing your data, don't try to remake Excel in Unreal or Unity. I've seen people try. Okay, there's like a decade's worth of, if not more, of work that's gone behind these tools. You're not going to recreate it in any sort of good fashion. If your editors of choice already support most of the stuff that you want to do, don't write bespoke tools. Okay? Designers and artists and all those guys will be very familiar with the tools that are available to them, and handing them bespoke tools really just complicates matters. So ask yourself, do I really need a bespoke tool for what we're doing? Okay, I know that like a lot of coders just like to write them for the sake of it because it's fun to write new stuff. Okay, but really ask yourself whether or not that is a requirement. And this one is another funny one. Just talk to the designers about what they need and what they want. So for example, we have 3 mechanisms for dealing with data. And they all have their pros and cons depending on how often we need to update the data, how much data there is, whether or not it needs live patching, etc., etc. We always sit down with the designers and we talk through what they want to build, how often they're going to want to update it, do they expect to be able to live patch it, do they expect to be able to just, you know, put new data into a new build, etc., etc. Okay? And again, use it for yourself. And yeah, again. So yeah, focused. This was an interesting one. We have editors where there's like a load of options, and some of those options aren't relevant to some of the things that you might be making in it. So like there might be 10 different like assets that this one editor can produce, and some of the options aren't relevant to all of the assets. And it actually turned out the designers found this really confusing, and also because there was no documentation, which didn't help. So yeah, if you've got editors like this, limit the amount that it's exposed to people just to the things that are relevant to the thing that they are trying to do at the time that they're trying to do it. It's really the same as enforcement. Like if things have limits on them, enforce those limits. This is another one of my bugbears. Whereas go like, oh yeah, you know, values need to be between 0 and 1, but I've left it so that they can put whatever the hell they like into it. Don't do that. Yes. Flexibility doesn't mean infinite possibilities, and this has been a very hard lesson for me to learn. Okay, I always try to make things that will do every single thing I can possibly think the designers might want to do with it. And cater to your circumstances, which is what we're going to talk about right now. So, who saw my last talk? There we go. Okay, it was so good. The system I built was so good. Well, I'm back to this. All right, it was great. I loved it, but it did have issues. So very, very quick overview of this. I had this idea that there are with our combat effects. So our combat effects are basically like everything that happens in our game. All of the barrels, all of the fireballs, all of the hitting things, all of the healing, everything. Okay, basically ran through this system. And we had this great idea of like generators would like make these combat effects and it would hand them out to a group of distributors, and then the distributors could distribute them out to a group of receivers. Okay, it was abstract, it was modular, it was awesome. And we had this stuff. This was our generator data. So we had this idea of generator data, and generator data would take a little link to some effect data. The idea being that generators, you could reuse your effects and give them to different generators and making it nice and modular. And then we had this idea, which was this visual command set, which was basically a set of visuals that could run out, and there was a whole editor for this that I'll show you in a minute. And this is our effect data, where we had this idea of like picking data, which would describe what your player's allowed to tap on, and then there's like targeting data, which was based on what you've picked, what you could target. Then there's modifiers, which describe, like this one's a damage modifier that's unblockable. And then there was some more targeting data that would describe, given what you've picked and what you've targeted, the number of what receivers you get for it. Okay. It was great. Yeah, and then we had these little guys, which were our visual command sets. And we had this editor, which hopefully, oh, I knew it was going to do that. There we go. So yeah, this is a tool I wrote. Okay, I have come to the conclusion I am not a tools programmer. Okay, and shouldn't be allowed near tools. Okay, so yeah, we had this idea of like there's all these like little commands that can run, and they can run in parallel or series, and you can wait for commands, and you can put whole like sub lists together of things that need to wait for each other, and it was great. Okay, you could basically build a set of visuals that would play out basically anything you could possibly imagine. Okay, but it's important to know that everything that I just showed you represented one of the simplest effects in our game, and there was the problem. Okay, the system was so modular and so flexible that the simplest thing to do became actually really quite complicated. And one of the problems that we had was that the data structures and the way that I built all of those data structures out and built the visuals was based on the code that I wrote. I wrote this massive modular system, but every single sort of module that I built meant that the designers, there was an asset for each piece, and the designers had to put all of those pieces together, which meant that even for a simple thing, this jigsaw of pieces had to be constructed. And when I talked about catering to our circumstances, like a lot of my history is actually working for AAA studios. So I'm like, yeah, it's going to be great. We're going to have dedicated teams of designers and VFX guys, and they're going to just be using this constantly, and all they're going to be doing is making tools. No, I had one designer, okay, on our team. I had no dedicated tools programmers. We had me, and we've already established that I'm not a good tools programmer. And 95% of the effects that we wound up making didn't actually use this distributor, and they didn't use the effect or generator separation. We had all this flexibility, and it simply wasn't being used. Okay, and in the end, I built a tool that I understood. Okay, when I made that tool 3 times, and that's where it landed. That was the best version of it. But I built it with so much knowledge of how the system worked that I was the one that wound up using it all the time. I wound up making most of the visual command sets for the entire game. I'm the tech director. It's really weird. So this was me, okay, because basically I already knew that there were problems with this system. But one of the really good things was that because design were very unhappy, it meant the management were quite unhappy. And although I built this in tandem with design, what happened was we came to a point where we needed to rebalance all of the effects in the game. And we needed to tweak a bunch of things about the visuals and a bunch of other stuff. And it turned into an absolute nightmare. Okay, it took us somewhere approaching a month to rework a bunch of effects in a game. Okay, again, that flexibility really just bit us. So what did we do? I did that. I got rid of this. So I rewrote this entire system. I'd spent a year, like, basically getting this to the point. I just deleted it. I got rid of it entirely. And it's important to notice that just because I deleted this, it didn't remove the requirement for this. Okay, the system still required the kind of mechanism by which you could do this sort of three-part distribution of effects, because it was there for a reason. Okay, and the solution that I came up with, which was to basically have this idea that generators could give something to a receiver and turn the receiver into a generator, was actually way more complicated. And it took me a long time to get it working. It's why I didn't do it that way in the first place, okay? But what it meant was that the complexity was limited to the 5% of use cases. So what I've done is I've put all of the complexity in the least used place, so that most of the time, the designers don't have to worry about it. Also, much to my sadness, got rid of the whole concept of VCSs entirely, okay? We simply didn't have the time or the resource or the inclination to build things this way. What did we replace it with? We replaced it with this. This is a giant Excel spreadsheet. Yeah, apparently designers love this. So, okay. So what you're going to see is there's a bunch of really familiar things here. Look, there's like picking, and there's targeting, and there's like mod targeting over here. These lovely drop-down lists that auto-populate themselves from the assets that are in your projects folders and all this jazz. They love it because what I didn't do, we didn't have to remake all of those individual pieces. Okay, what I actually did was remove some of the complexity from the most common path, and allowed them to much more easily assemble all of these parts. And what it meant was that a designer could, you know, like one of our designers could do all of this, and then you can just copy and paste the line, and you can change a few things. If you want to rebalance all of your numbers, it takes about 5 minutes now to rebalance every number in the game. Okay, one great thing here. So what happened to the visual command sets? Well, there's one little line here. It's like, look, the column for VFX. So what I did was we sat down and we realized that actually, for all of that flexibility that I gave them, there were really only 6 types of visual effect flows that played out, okay? And they were these 6 things here. And I wrote some documentation. There's a lot more to this documentation that basically describes what each one of those means and how the VFX flow. There's like chain lightning. I think chain lightning is this one. Yes, where basically you can like fire a lightning bolt and the lightning bolt will go to the first guy, then the lightning bolt will go to the second person, and then the lightning bolt will go to the next one. Okay? All the VFX guys had to do was make a lightning bolt. So I hard coded basically these 6 kind of logic, these 6 bits of targeting logic. And what it meant was that we'd already had, like, all of these VFX were already made. Okay, we didn't want to go back and remake all of these VFX over and over again. So instead, I made sure that we didn't have to redo any of our assets. Okay, all I did was, instead of allowing the designers to assemble all of this logic, I gave them the choice of 6 bits of logic. The other thing about this was that we also realized that every time you attack, you want to play the attack animation. Okay, every time you get hit, you actually just want to play your hit animation, and you want to update your health bar, and etc., etc. We realized that a lot of these things were actually just fixed anyway, so we fixed them. I fixed them in code. We went round a bunch of iterations with art and design, and we landed on the fact that there are certain flows that always play out the same. So that was another big win with the visuals. And the final one was this idea. Oh, look, tooltips. The final one was this idea, which is that some modifiers, like this one, this is a strength modifier. It plays a little like strength appears above your head when you get it. So again, we've got all of these were leftover visuals. This just basically tells it to play like some text above a character's head. It meant that our senior designer could build up a bunch of these little modifiers, put all of the visuals in those modifiers, and then anybody that wants to use that can just go back to the Excel, they can pick it out of a list, they go, oh, I just want to give it strength, okay? And at that point, you know every single visual that is required to get it to the point where strength appears at the right time is all taken care of for you. The designers that put together the things in the Excel spreadsheet never have to think about the visuals. They all just work. So yeah, that was me in design after we finished all of this. It was a massive undertaking, to be fair, okay? But we'd spent so much time and money rebalancing the effects in the game that it was decided that it was worth the effort. Okay. The last group, the most reasonable of our users. So, players. Yeah, players. They'd like your game, they'd like things to be fast, and this I'm going to focus on some very specific meanings of this. There's loading times. Frictionless, because for some reason they feel that they're entitled to just whiz around your game and have access to everything all at once, no matter where it is or what you're doing. Fancy, I'll get to in a minute, I just like the 3 Fs. They also like it to be challenging, but easy to master. They like it to be free, but they don't want it to be cheap. They want it to be bug-free, but they want it to be deep and complex, okay? Yeah, users have a lot of outrageous expectations of your game. And I could focus on, I think, any single one of those as an entire talk. But I'm going to focus on, yeah, just these guys. So this one is load times. Primarily, you know, I work on mobile at the moment, although the PS5 has done a really good job of like showing people what it's like not to have load times in anything. But if you work on mobile, there's a strong link between retention and load times. Okay. Frictionless. This one goes hand in hand with fast. Players expect to be able to, yeah, whiz around your game no matter what device they're on. We get people complaining and they're on some like 6-year-old 1 gig device going, the game's really slow. And you're like, well, yes, of course it's slow. You're on a 6-year-old device, okay? But they still expect it to be this good. And fancy. Yeah, as I said, I just wanted 3 F words at this point. Yeah, they have really high expectations. Like on mobile, it's outrageous, the expectations of quality in your game. Not just in terms of like textures and, you know, your poly counts and how many particles you can get on, but there's a lot of nuance to this that our studio manager and our art director have basically like really helped me learn how much nuance there is in going around your game and how much work goes into making it all feel seamless and polished. So I'm going to talk about our state loading system. We are on our 3rd iteration of our state loading system. Almost every game you ever work on will have a state loading system of some sort, okay? And it's actually, I worked out the primary place where you will sink or swim when it comes to those 3 priorities. So version 1, okay, we had our initial loading of the game, and goes over to a state manager. Our state manager takes you into what we call a major state, like our hub state. We're looking at a pretty little village. Then we load all of these little minor states, and then when we're done, we get into our game. This was awful, okay? This was the first way I built it, and it led to, on low end, it could take 2 minutes to get into a game, okay? And on mobile, you may as well just shut up shop at that point, because your day 1 retention is going to just, I don't think we got up like 10%. It was something shocking, right? Yeah, and so this was a major problem. And when we first built this, design were like, no, it'll be fine. We're just going to load everything, okay? And from a frictionless kind of point of view, it actually worked really well. We loaded everything into memory. It took a bloody long time to get there. But once you were there, moving around our game was really, really slick and easy. But it had 2 major flaws, right? Yeah. The first is that because you can't cram everything into a 1 gig device, we made the cardinal sin of just starting to like downgrade everything until it finally would fit and we wouldn't blow up our lowest end devices, okay? And what that means is like every single person that's on a $2,000 phone, I likened it to this, where you buy a first class seat. They got this $2,000 phone and they're like, yeah, it's going to be great. And then when they turn up, this is the seat they get. And Yeah, because they find out that they're getting exactly the same experience as the person on a $200 phone. And they, especially in mobile, the people on the really good phones are going to be the most vocal people about your game. They're also going to be the highest spenders in your game. So you want to make sure that they get the most premium experience possible. So what we knew we had to do for a start was differentiate between these two groups of people, or actually multiple groups of people. So we came up with a way of, when you run our game, it profiles your device and it has a bunch of metrics and weightings, and we put you into a category of low, medium, high. We in fact had like ultra low, because Android, low, medium, high, and then like ultra high because things are getting ridiculous. Yeah, and we would have our initial loading. I'm going to skip over these bits, but we did a load of work in here using async functions to kick off a load of our loading, but never waiting for it. And on high-end devices, it meant that by the time we actually got to like our scene being loaded, everything else had finished anyway. So we practically halved our load times just by doing that. And there's some links to async stuff for Unity, which I thoroughly recommend. Don't have a single code routine in our game. Yes, so we would load into our hub. So yeah, now we have this idea. We have this concept of low end and high end, and we have this way of deciding on low end. Well, actually, we're not going to load these things into memory. They can be on demand. When somebody wants to go into like the barracks, we'll just load the barracks state when they want to go in it, and when they come out of it, we will unload the barracks state. On high end though, now you can have it all. Don't worry about it. And we run all of these in parallel. We kick them all off and we just go, as soon as they're ready, they're loaded into memory. And yeah, as soon as like basically everything is finished, you're back into the game again. So, yes, these profiles wound up being brilliant. It meant that we could do things like decide what sort of models to load, what textures to load. We can set the render pipeline per state in our game so that we can switch on and off different effects. So on our high end now, like our tech artists were laughing. They're like, we can do so much on high end phones now that we know that we're on them. Okay, Unitask, async tasks in Unity. 2 bits of code that I won't go through. These are basically ways for other parts of your code to wait for a load of async things to finish. We've got hundreds of these in our game. Probably the most used code I've ever written. Okay, so you might think that we've arrived, but we haven't arrived. Okay, one of the major problems again that we had was fast and frictionless is actually working out really well. But we found 2 things. One, when we moved this system to another game, where we started to have way more of these minor states, performance on our low end just tanked. Okay, and what we found out was that kicking off a ton of async tasks eventually just choked the hardware. Yeah, you basically just choke your low end entirely. It can't keep up. And then, unbeknownst to me, but I figured it out eventually, is that somebody added this minor state to our game for daily login. And the designers were like, hey, the daily login should be the first thing you see when you come into the hub. So in our naivety, what we did was we went, all right, we'll just wait for it to load then. And then once it's loaded, we'll show it to you. Which basically meant everything was left waiting for this thing to finish loading. It happened to be the slowest thing to load in the game because it has a ton of stuff that it actually needs to check, get from the database, needs to load up a bunch of like live data, it needs to instantiate so many bits and pieces, okay? So, but on the fancy front as well, we're doing all right here. So, yeah, this was our major problem. This led us to state loading system version 3. Everything is basically the same up until this point. We went back to this idea of sequential loading rather than running everything in parallel because we really were just choking the low end. I'm still deciding whether or not to make our high end do everything in parallel and our low end not. You don't really notice anymore. But basically we don't wait for any of it anymore. We just go, nah, don't worry about it. Get straight into the game. Okay? All of these minor states now are independent by default. Okay, you can make the system wait on something if you want, And yeah, the system is smart enough now so that when you're in the hub, if the user decides to tap on any minor state, it gets pushed to the top of the loading queue. So if it's not already loaded, it is the next thing that gets loaded. And on high end, even though we're doing this like sequential thing, never even notice, like, because it takes milliseconds to get into any state. So yeah, we finally wound up with a state system that basically does everything we could possibly need it to. But there's a little bit more on the fancy front. So when we first built the other two systems, we suddenly realized that art and design wanted to do loads of things when we were transitioning between states, and there's all these like pretty effects that go on, there's animations that play, there's waiting, there's like loading things that need to pop up only if you're actually loading stuff, like you're on a low-end device. And retrofitting that to our game also turned out to be a nightmare. So this time we built it into our core system. So when we change major states, we have this idea of major state transitions are like your giant ones. It's where we basically do all the loading and we can do all of our garbage collection and everything else. Always happens between a state loading screen. But it's fully customizable. You can tell it just to use any old through interfaces. It's great. Going into a minor state can show transition effects. You can make it show whatever transition effects you want, basically. Again, through interfaces, we just pass through and say, hey, here's the transition that I want you to do, wait for it to be finished. And the system goes, you're all right. Minor states can also be shown to, different criteria. So if you've been in the state before, it knows it. And if you haven't, it can play an entirely different set of criteria for you. Remember the daily login? Minor states can be set to automatically show themselves when they're ready based on what state you're in. And yeah, minor states can show transitions that adapt based on like how long it's taking to load things. So we have like these fade to blacks, which look really slick. But on low end, if it takes too long, then it will change itself into like a loading spinner and stuff like that. So you're never leaving your low end users staring at a black screen for any amount of time. And yeah, hopefully, this is a video. So here we are loading into our game. It's pretty quick. There's a transition. I left that one in. Did anyone see that little spinner that came up? Looks arse, doesn't it? And it shows you the nuance thing. It looks terrible, okay? And people will notice that and be like, well, that was a bit rubbish. It's on my list of things to fix because it shouldn't actually be appearing at that point. Here we go, we're going out. So there's the daily login screen. So it was ready, and we would have waited. So initially, we would have waited all of that extra amount of time just to get into the game because this thing was loading itself. Yeah, there we go. Put some stuff up. Here we are. We're transitioning into a minor state that we've never been to before. And all of this stuff is being kicked off by our state loading system. And yeah, here we are. That was a nice fade to black transition. That one does turn into something else. And more little fade to black things coming out of things. Going back to the hub. Thank you. That was my sort of 48 minutes. Yes, I am hiring. And if anyone can ask a question in 2 minutes. Anyone have a question?
Should we do these two? Do you want to go first?
Sure. Hey, great talk. I was wondering if you've seen the Unreal game playability system for inspiration.
Yes, I have. So, funnily enough, because we do have an Unreal project as well, and when I started to rebuild that system, the lead coder on that project wanted to talk to me about that, and we actually found out that we have a lot of very, very similar like underlying concepts that are going on. Kind of wish I'd heard about it before. It's one of those things that I'd basically written it afterwards. But yes, it's very cool.
Hey, one of the big problems with user tests is that users will suggest solutions rather than highlighting problems. Sometimes I found that you get the same thing with designers where they will start telling you like what they think you will be able to deliver easily rather than what they actually want. do you have any like strategies when you're talking to designers to get them to say, we would like to do all these 17 things, and then you can say, well, we can do these 4, rather than saying, we'd like this one, please?
Yeah, yeah, I do actually. So the way that I always ask our designers to go about, before we do a user story, we basically do like a pitch for a feature, and I ask them to do what's known as bookending it. So I ask them for what's the simplest possible thing that you can think that you're going to want to do with this system. And then I ask them that blue sky, what's the single most complicated thing you can possibly think that you would want to do with this system? And yeah, like not based on code, not based on tech, not based on what we've got, what you think we might have, just literally what's the coolest thing you could possibly think of doing. And I use those bookends for our user story conversations, where we then build down and focus in on what we can deliver and how long it's going to take to deliver it. So yeah, that's a good idea. Cool. Well, thank you very much. That was a bit of a whirlwind.